We proposed a new sampling-based controllable zero-shot image captioning framework, namely ConZIC. Traditional image captioning methods are generally designed in an autoencoder pipeline. The image is firstly input into an image encoder to get the visual feature. And then the visual feature will be input into the text decoder to generate a caption. The whole framework needs well-prepared image-text pairs for supervised training. Due to the IID assumption, traditional methods can't generate descriptions for novel objects not existed in training data, which brings limitations to robustness and diversity. As large-scale pre-trained models become more popular, zero-shot capability has been considered a new revolution of deep learning, letting machines work on tasks without curated training data. Zero-shot image captioning methods utilize a large multimodal model to adjust the word searching space of a large language model to force the generated texts to match the image content. Equipped with the visual language knowledge learned by large multimodal models like CLIP and linguistic knowledge from large language models like GPT, zero-shot image captioning methods can do image captioning without any extra training process. Besides, extensive visual concepts and world knowledge contained in CLIP and GPT make the generalization capability of zero-shot image captioning methods much closer to human beings. However, previous zero-shot image captioning methods usually adopt autoregressive language model like GPT-2 as their text generator, leading to a common generation problem, namely mode collapse. For a single image, previous methods have an unsatisfactory ability for generating diverse captions in various syntactic patterns and a large vocabulary, which is easy for humans. And human-like controllability such as sentiments and textual styles, is unexplored for previous zero-shot image captioning methods. Besides, another key motivation of our work is that left-to-right autoregressive generations have no chance to modify words that have been generated and can only take left-side context into account. In fact, previous zero-shot image captioning methods are hard to generate an accurate caption once without training on curated image captioning data. Thus, the core of our proposed method is an iterative non-autoregressive language model, namely Gibbs-BERT. Gibbs sampling is a Markov chain Monte Carlo algorithm, which aims to collect samples from the sentence distribution by sampling each word iteratively from its conditional probability. At the same time, the conditional word probability is modeled by BERT in the pre-training stage. By combining Gibbs sampling and BERT, Gibbs-BERT can generate a sentence from a full mask sequence in an iterative way. For the first iteration, BERT samples word by word in arbitrary order from a full mask sequence but has some language difficulties. And then in the next iteration Gibbs-BERT uses a mask token to replace the generated words and then generated a new word. After a few iterations, the sentence gets smoother, which we called the polishing mechanism. The polishing mechanism means that we can modify the generated inaccurate words or some syntax errors. The whole pipeline of our proposed ConZIC is that we first get a word distribution from the original BERT, then select the top K candidate words and combine them with the context to get K candidate sentence. We input the image and all candidate sentences into CLIP and get the image matching probability after normalization. Meanwhile, we input candidate sentences into a linguistic discriminator to get the controllable probability. By adding the image matching, controllable, an original BERT word distribution, we can get the final adjusted word distribution and sample the final word from it. In a word, the target of ConZIC is to adjust the word distribution of each word sampling step in Gibbs-BERT to match the image content and meet some predefined control signals. For example, given the input and the predefined control signals, ConZIC can iteratively refine sentence to get more image-related and fluent. Here is the performance on Mskoko caption dataset. Obviously, for traditional supervised accuracy-based metrics, zero-shot methods without any fine-tuning lag behind other supervised methods because they can benefit from the domain bias of training data. But for semantic-related metrics clip score and ref clip score, our proposed method can get comparable and superior performance to demonstrate our ability to generate accurate captions, though is not Coco's style. For diversity metrics, compared to the other diversity-based methods, our method surpassed them by a large margin and improved by about 1.5 times. As shown in the iterative curve, our proposed polishing mechanism can significantly improve the performance of the model compared with the previous method. Meanwhile, the time consumption of our method is lower. Here are some examples of controllable generation and comparison with other SOTA algorithms. For one image, ConZIC can generate captions with a good balance of accuracy, controllability, and diversity. For example, for positive captioning, we can generate various positive words, like cute, happy, amazed, healthy, and smiling. For negative, bad, sad, and lonely. Compared with previous methods, which tend to generate general captions, our generations are much richer. The non-autoregressive nature and flexible generation order of our methods bring high diversity in syntactic patterns and vocabulary and effectively alleviate the model collapse problem. For the same object, our method can produce diverse descriptions. As for images with world knowledge, our method can capture relevant visual concepts. For example, a CT medical photo with brain samples, the famous Gauche painting, namely The Starry Night, and a photo of New York Times Square. We have conducted other controllable generation tasks such as length control, style control, and part-of-speech control. More results are shown in our paper. Thanks for watching.